Hi, Assalamualaikum. We are from Group 4, SEG. Today, we would like to present our project title, Groundwater Quality Assessment. This is my group members. Firstly, I will explain the introduction of the study. Groundwater is an important source of fresh water for domestic, agricultural, and industrial use. However, groundwater quality can be influenced by various physical and environmental factors. In this study, total dissolved solids or TDS was used as an indicator of groundwater quality. The objective was to examine how well depth, distance from potential contaminant source, and elevation influence TDS levels using multiple linear regression analysis. So what is SPSS? SPSS, or Statistical Package for the Social Sciences, is a statistical software used to organize, manage, and analyze data. It is widely used in research because it can generate tables, graphs, and statistical outputs automatically. In this study, SPSS was used for descriptive statistics, present correlation analysis, and multiple linear regression analysis. Alright, let's move to this step first. We created the variables in variable view and enter the dataset consisting of 20 observations into data view. Next, descriptive statistics were generated to obtain the median, mean, standard deviation, minimum value, and maximum value for each variable. After that, Pearson correlation analysis was conducted to examine the relationship between variables. A histogram and scatter plots were also generated to visualize the data distribution and relationships between TDS and the independent variables. Finally, multiple linear regression analysis was performed. TDS was entered as the dependent variable, while well depth, distance, and elevation were entered as independent variables. SPSS then generated the model summary, ANOVA, and coefficients table, which were used to evaluate the regression models.
Bismillahirrahmanirrahim. My name is Muhammad Amirul Hakimi bin Alimuddin. My metric number is 824A3295. So today I will be presenting the dependent variable used in our study, which is total dissolved solid or TDS. For our group topic, which is the groundwater quality assessment. So before discussing the result, I would like to briefly explain how I analyze the TDS data using the SPSS software. So first step, I enter all 20 observations into SPSS software. Then the variable total dissolved solid or TDS was defined as the dependent variable and measured in milligram per liter mgl. Then after entering the data, I use the descriptive statistic function in SPSS by selecting analyze, then descriptive statistic, and finally descriptive. This allows me to obtain important statistical measures such as the mean, standard, deviation, minimum value, and maximum value for TDS. Next, to examine the distribution of TDS value, I create a histogram using the graph function in the SPSS. This helps us to visualize how the TDS value will distribute across the 20 monitoring wells. Then the results show that the mean TDS value is 3.46 mgl, while the median is 3.55 mgl. This means that the average groundwater sample in our study contains approximately 3.46 mgl of dissolved solid. Then the minimum TDS value recorded is 2.5 mgl and the maximum value is 4.3 mgl. In addition, the standard deviation of TDS is 0.56 at this relatively small value indicates that the TDS measurement do not vary greatly between the monitoring wells, suggesting a moderate level of consistency in groundwater quality throughout the study area. Based on the histogram produced in SPSS, most TDS values are concentrated around the mean value of 3.46 mgl. This indicates that the groundwater quality measurements are relatively balanced and do not show extreme variation. Next, to further investigate the factor affecting TDS, we perform person correlation analysis in SPSS. The results show that TDS has very strong positive correlation with well depth with a correlation coefficient of 0.980. This means that the deeper wells tend to have higher TDS concentration. TDS also has a strong positive correlation with distance from potential contamination source with a correlation coefficient of 0.9962. Meanwhile, TDS has a strong negative correlation with elevation with a correlation coefficient of negative 0.912, indicating that groundwater collected at higher elevation generally contain lower TDS level. So in a conclusion, TDS was selected as the dependent variable because it's an important indicator of groundwater quality. Using SPSS software, we were able to analyze its distribution and the relationship with the independent variable. The results show that TDS is strongly influenced by well depth, distance from the potential contaminant source, and elevation, making it valuable measure for assessing groundwater quality. So that's all for me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh to Dr. Siti Ansha and everyone. I am Muhammad Arifi bin Muhammad and I am presenting independent variable B well depth measured in meters. In our hydrogeological assessment, well depth is a critical vertical parameter. It acts as a direct proxy for groundwater resistance time, meaning deeper well tap into older water that has had prolonged exposure to rock strata, driving up mineral dissolution. Across our 20 monitoring wells, depth range from 70 to 150 meter, averaging 112.75 meter. Analyzed completely on its own, well depth is an incredibly powerful predictor. The Pearson correlation show a near perfect positive relationship with TDS at 0.980 individually. Our bivariate scatter plot revealed that well depth alone explained an outstanding 69% of the total variance in groundwater mineralization. When combined into our final multiple linear regression model, well depth completely dominates. It is the only individual predictor that retains strong statistical significance with a p-value of less than 0.001, holding all other spatial factors constant every 1 meter. Increase in depth increase TDS by 0.016 per liter with a standardized beta of 0.660. It exerts the absolute highest relative influence on groundwater quality. Why did the other two spatial variables drop out of individual significance? Because of severe multicollinearity, a well depth has a high VIF of 9.906 in our study basin. Deeper wells structurally correspond with lower elevation and further distance. Because they overlap, well depth successfully absorb the shear variance, leaving the other variables statistically insignificant in the combined model. In conclusion, our report prove that the well depth is the primary physical mechanism driving groundwater TDS. The core takeaway is that drilling deeper is not always better for water quality. So we recommend the optimizing shallow to medium well depth to control baseline mineralization. Thank you, and I will now hand the floor over to member 4.
Hello, my name is Muhammad Amar Ashmawi from Masani, number matric E24A3305. So next, I will explain the third independent variable used in this study, which is distance from the potential contaminant source measured in meters. This variable refers to the distance between each monitoring well and a possible source of contamination, such as agricultural activities, industrial operation, or waste disposal areas. It was included in the analysis because contaminant source can influence the groundwater quality and affect the concentration of total dissolved solid or TDS. Based on the dataset, the distance value range from 430 meters to 620 meters. with an average distance of 523.5 meters. The Pearson correlation analysis shows a strong positive relationship between distance and TDS, with a correlation coefficient of 0.962. This indicates that change in the distance from a contaminant source are closely associated with change in TDS level. Therefore, distance from the potential contaminant source is an important variable in the study, as it helps us better understand the factors that influence groundwater quality and contribute to the prediction of TDS concentration in the aquifer system. So that's all from me. Thank you.
Assalamualaikum and hi everyone. I am Muhammad Amar bin Saharuddin with a matric number of E24A3271. And so for my section, I will discuss the fourth independent variable, which is elevation measured in meters. So based on the descriptive statistics, the elevation values range from 20 meters to 24.2 meters, with a mean elevation of 22.2 meters and a standard deviation of 1.22 meters. This indicates that the sampling locations had a relatively small variation in elevation. And next, let's look at the relationship between elevation and total dissolved solids, or also known as TDS in short. The Pearson correlation coefficient between elevation and TDS is negative 0.912, with a significance value of P is less than 0.001. This shows a very strong negative correlation between those two variables. So in other words, as elevation increases, the TDS concentration will tend to decrease significantly. This relationship can be seen in this catapult below, as the regression equation is y equals to 12.9 minus by 0.43x. So this equation indicates that for every 1 meter increase in elevation, the TDS value decreases by approximately 0.43 units. And the graph also shows an R square value of 0.832, meaning that about 83.2% of the variation in TDS can be explained by the elevation alone. But, however, when elevation was included together with well depth and distance in the multiple regression model, the significance value of the elevation was dropped to 0.778, which is greater than 0.05, which means that the elevation was not a significant predictor of TDS when the effects of the other variables were considered simultaneously. So in conclusion, for my part, the elevation shows a very strong negative relationship with TDS when analyzed individually, but its influence become less important in multiple regression model because due to the stronger effects of other variables such as well depth and distance. That is all from me. Thank you.
In conclusion, groundwater quality was successfully assessed using multiple linear regression analysis. The study examined the effects of well depth, distance from potential contaminant source, and elevation on total dissolved solids, or TDS. The regression model performed very well with an R square value of 0.971, indicating that 97.1% of the variation in TDS can be explained by the selected variables. Among all predictors, well depth was identified as the most significant factor affecting groundwater quality. Overall, the developed model is reliable and can be used to predict groundwater quality and support future groundwater management decisions. And that's all from us. Thank you.